I didn't see you there. I thought I would record a video for you, and it's on a concept that I've been struggling with myself, because I've been trying to increase my own Khan Academy mastery percentage on AP Calculus. You can see it right here. It's the Riemann sums and summation notation, and I've got well, I answered it correctly. It was kind of a guess, an educated guess, and so I was going to try to take this information and re-explain it as I work on a new problem, and then try my answer, see if it's right. If it's wrong, we'll learn together about what I needed to do in order to get it right. This question, if you've seen it, or if you haven't tried these yet, some of you are working on your percentage points, because that's what I want you to do. Like right now, one person in the class has a higher percentage in the total Khan Academy mastery score than I do. So challenges for you all to get to at least 80%. And right now I'm at 84, so okay. The question that I have, Riemann sums in summation notation. It's out of the integration and accumulation of change topic. And the question that I have is these purple rectangles, really summarizing here, these purple rectangles, we're adding them up from the right side edge. This is a right Riemann sum approximation. And we want to choose the best answer in order to determine well, one, how does this notation connect back? And so that's my goal right now. There are 5 explanation points that they gave for this question, and so I'll just leave them there. You can pause and read it yourself. I'm going to take a sip of coffee while I pause. So excited I bought a teapot today so that I can make French press. I mean, I could do that already. You have to have the French press thing, but the kettle actually heats the water better than any. Okay, so maybe you like looked at 3 and 4. Step 4 is the long one. Step 4 is the aha, that's what's going on moment. And so, you know, maybe like I'll scroll through this a little bit and read it too. But then I'm planning on explaining it here in a second. So another sip of coffee. All right, and show the rest. Okay, here we go. So next question. Using what you may have read there or didn't, we're going to go through this one together. Some things that I noticed, and I'll try to capture my notes over here. Riemann sums in summation notation. The structure of a Riemann sum is that when you want to talk about the area under the curve, you look for all of the little rectangles that you can add up. And when you have more rectangles, you get a more close guess as to what the actual area under the curve is. So we're looking at all of those little strips as we add up. One of the things I remember we talked about, so this is somewhat of a review, you can look at a left side, right side. So a left Riemann sum, the line, the rectangle, that strip is formed by going up to the curve. And every interval you go up to the curve from the left side and form your rectangle. Right Riemann's the other side. You go from the right side and work the other way. Okay, so in this problem, I have a function. I have f of x equals square root x plus 5. And the notation for a summation uses the sum of the index from m to n of sum f of x sub I times delta x. So in order to answer this question, you know, choose the appropriate thing. We need to be able to fill in m in x sub I, f of x sub I, and delta x. And all of that is what's done. The first thing that happened, if you think back, you know, go back in the video, scrub back. Oh, I should say this every time too. It's a math video, so if you're just interested in the solution, skip to the end. If I'm telling you information you already know, just slide that bar along on the YouTube line until you get to the point where you're like, oh, that is new material. Okay, so the interval goes from 1 to 3. So step 1 should be calculate delta x. Delta x is going to be from 1 to 3, so we'll find their difference. And then it's divided by, I see it right here, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 equal subdivisions. So we're going to divide by 8 and get our answer. Like I said, I don't know the answer yet, so I'm going to, kind of guess my way there and get to an educated guess and explain why it's an educated guess, or get to the complete and this is its answer, the solve. But delta x is 1/4. And so that's going to be used, that might eliminate option A and option D. I don't know. But thinking about how the end decimal is 0.25 gives me an idea that there's got to be some element of what's going on. Okay. Second thing we need to do is, I caught this as I was reading through that example as well. If we're doing an LRAM, then we should say that I equals 0. We're going from 0 to 8, or 0 up to, well, that's got me thinking now. Maybe we do, maybe we don't. I don't know. We'll just cross that bridge when we get there. In an RRAM, it's typical to say that I equals 1. So for us, I guess letting that guide things, that's talking about our starting point. This is whether we're choosing M for some value of information. So we've got delta x, it's 1/4. It's an LRAM. I know it's an LRAM because when I look at these rectangles, the rectangles are formed where the left corner touches the function. So from the left side, we form the rectangle. This is an LRAM, a left Riemann approximation method. We need to figure out our f of x sub I. We know what f of x is, but f of x sub I is the key thing. And so I'm curious here. It seems like, this is the part that I was like, oh my gosh, that's really the way you're thinking about it. The way that x grows as it goes along the interval, this x sub I here inside the summation is like a linear equation. So think of our point slope, the best method, the best model for a linear equation. And I don't like writing it that way. I write it like this. So what we're going to do is we're going to take the information from here, and I'm pointing. You can't see what I'm pointing at. We're taking the information from the graph, and we're going to translate it over here into this linear equation model. So for the first one, y is going to be called x sub I. We're looking for a formula that generates how x sub I changes as we go from the first I, meaning like right there, to the next I, if you're looking at the graph right there, to the next I, to the next I. So x sub I is a formula. It is equal to how much change. Every time there is change, we have a new x sub I is different from the previous one by that delta x. So we're going to put a 1/4. This 1/4 is also the m in the formula. X is still there. It does depend on whatever x we're talking about. So x sub I is different from x, but it's going to use x. And if we look down here in the formula, there's this 0.25. I think, yep. Okay, so I'm still on the right track. Okay, so then the next one. This x sub 1, right, that's just waiting for an x-coordinate, y-coordinate relationship. And one of our x-coordinate, y-coordinate relationships says, this is where I got a little tripped up. Yeah. Okay. So this says that like they used in the previous example, they said f of x sub 10, the last number, the last interval was on the 7. For us, I'm going to say the 0. I'm going to say x sub 0 equals 1. So what that tells me is x minus 0 plus 1 completes the relationship. Now we're going to start at 1 and we're going to add a 4th every time. And I'm still curious about the notation. So we'll just keep going forward, and then if I get stuck, we'll just backtrack and release the video or not. I'll probably release it. Okay, so I'm going to say that x sub I is 1/4 x plus 1. So up here in this formula, I now have this formula. I now can put this for the x sub 1 spacing. I can go square root 1/4 x plus 1 plus 5. Okay, I'm back to stuck again. I'm stuck again because I'm looking at my answer choices and none of them have an X in there, which I'm still curious about. Why wouldn't there be an X? Well, charge forward and see what we get to. Okay, so a lot of math on the screen, just let it be a thing, or on the paper, let it be its own thing, and we'll just kind of talk about it again. Again, I'm still thinking that because this change, the spacing or width of each rectangle is a quarter, that I am limited between B and C. So I'm going to just kind of put a little, not you. That didn't do what I wanted to do. Oh, come on now. Sorry for the clicking noises. I need to get a better mic. Okay, so notation, pointing. Uh-oh, we have laggy computer. Okay, so notation, I'm going to put 0 where M is and 8 where N is. They don't do that. 7, right? 0, so 0 would be where we start on the left side and we go up. So I'm even restricting myself. I'm saying that I'm getting closer to C being the right answer. I equals 0. 0 because it's a left Riemann sum approximation. And then we're going to go from 0 to the first one, I guess 0, 1, 2, 3, 4, 5, 6, 7. When you add up all of those numbers, 0 through 7 is 8 things. So we still have 0 to 7. That is 8 jumps. So we're still good with our number of subdivisions. F of x is this formula. So we have the formula 1/4 x plus 1 plus 5 times a fourth. I'm curious about why, like, if I'm leaning towards C, why there's a 0.25i. We'll just go through the learning thing together. And you check it. Here we go. Yes. Okay. Educated guess. Several things were helping me with the educated guess, feeling a huge sense of relief that they were done. The first one was I got to find delta x, and delta x manages to line up being 1/4, manages to line up with that decimal. Then the 1 to 3 kind of caught me, but we never put the limits of integration, the boundaries of the graph as our index. We want to put how many subdivisions. That's what the summing notation means. We're going to sum up how many things? Well, 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7 things. That's 8 things, eight spaces. Okay, this last part here, though, that I'm really stuck on that I don't quite understand is the 0.25i. So where is my step-by-step solution? Oh, they just use I here instead of x. So if it's the 0th iteration, we're on the 1. Meaning if I is 0. If I is 1, then we're on 1 plus a fourth. So how many fourth jumps do we need to make? So in my notes, I use I or X, and it's really an I that they're using in the problem. Whatever it is that your jump spacing distance, like you've jumped up 1 time, so where are you at? And you're at 1.25. You've jumped up 4 times, so that's 1, 2, 3, 4. You should be at 2. How can this formula produce a 2? If I is 4, meaning you've jumped 4 times, the I is the number of jumps that you've made. So we're adding up the after the first time and the second. Hey, I love it. I'm going to go ahead and cancel or pause, shut, whatever, Thanks for watching. Comment, like, and subscribe. Ring the bell for notifications. Don't forget to leave a comment or make your own video and all that other things that you hear. So I'll streamline the process in the future. But anyway, that's Riemann sums in summation notation. I'm going to go ahead and redo this one. I want the 80%. I missed one. So thanks. Bye.